Hello everyone. So now that you know how to use sine, cos and tan or identify them, let's see how they're used. Okay, so the first and easiest way to do it is, let's say I have and I want to find the sine of A, the cos of A, and the tan of A. So in order to find it, I need the three sides. So this brings us back to our first video. How do you find the three sides in a right angle triangle? We use Pythagoras. So if we're using Pythagoras, all we need to figure out is, do we have the longest side or not? If I have the longest side, that must mean one of the other sides is missing, which you can see is true. So if I have the longest side, then to find the missing side, it's just subtract. So x is 5. So now I have the three sides of my right angle triangle. I can now use my rules to find the sine. Remember, sine is opposite over hypotenuse, which is the longest side. The longest side is always opposite the right angle, so for our answers here, hypotenuse will always be 13. So what's opposite A? Opposite A, if I was standing at A and looking across, I'd see 12. Simple as that. So opposite must be 12. So the sine of A is opposite over hypotenuse, opposite over the longest side. The cos of A is adjacent. So if I was standing here, what am I standing on? I'm standing on the adjacent side, which is in this case 5, over the longest side, which is 13. And then the tan of A, well, that's just opposite over adjacent. It's basically what's across from me from what I'm standing on. And there's my three ratios. So they're not the angles, they're they are what's happened when you get the sine of that angle. So if I put an angle in here, some angle that I put into this calculator and get the sine of it will give me those three numbers. Okay? So that's the simplest type of sum that can be done. Now let's look at a little bit more tricky of a sum. Tiny bit more tricky of a sum. Build a triangle if the sine of the angle at A is 1 over the root of 2. Okay, so let's see how would I do that. So let's build a triangle. There's a right angle triangle built for me. Now, let's put A somewhere. It doesn't matter where I put A. I'm going to put it down here. So how would I build this triangle? How would I put the sides in? Well, I know that the sine of an angle is opposite over hypotenuse. So opposite the angle must be 1. So there's opposite, there's 1. And hypotenuse is always the longest side, so there's root 2. But I have to build it. I need to know what this is. So in order to find out, I go back to Pythagoras. He tells me how to find the missing side. And he says that if you have the longest side and you want one of the others, you just subtract. So let's call the missing side x. So x is going to be equal to the square root of this squared minus 1 squared. So let your calculator do the lifting here. Bracket square root of 2 squared minus 1 squared. And it's 1. So the other side must have been 1. So there you go. That's how you'll find it to build a triangle and find the missing side. You sketch it or draw it, put in what you know, and then use Pythagoras to find what's missing. Now, let's find the really hard one. So, here we have a giant triangle split in two to make two right angle triangles. Okay, let's say this is 62 degrees. Let's say this length here is x. This length here is b. And this length here is, no, I won't call it b. Let's make it something nicer. Let's make it 8. Let's make this y. That distance is y. And let's make this 37. And I want to find x and y. So you're looking at it and you're thinking, okay, let's see what I can do. Can I use Pythagoras? To use Pythagoras, I need 2 sides. I only have 1 side. I can't use Pythagoras. So I must use sine, cos, or tan. So let's see what I have. I don't have the hypotenuse of this small triangle. I have an angle. I want opposite the angle, and I have adjacent. So in other words, I have the cos of 62 is equal to x divided by 8. Now, this is a triangular formula, and if you're missing the top of a triangle, you just multiply the bottom by the other side. So that's going to be 8 times the cos of 62. Look, I'm using brackets, should be 8x. So let's check that. 8 cos 52. And let's round it to the nearest whole number to make it easy to do in the next bit. Let's call it 5. So now we know x is equal to 5. Now let's see how we can use that to get this. Same method. Look, I don't have enough information about this to use Pythagoras. I only have 1 side in this triangle. Okay, if I only have 1 side in this triangle, I have to use sine, cos, or tan. So let's see what I have. I have an angle. I have opposite the angle. And I want adjacent. So that's the tan. So that's the tan of 37 is equal to 5 over y. Now, if this is again another triangular formula, and if the bottom is missing, this is the trick. If the bottom is missing on a triangular formula, then the top and these are a division. Now, how do they divide? Well, it's simple. You divide the top of the fraction by what's on the other side. In this case, you just multiply them together, but when this one is missing, when the bottom is missing, you divide the top by the bottom. So let's try that. Fraction 5 over the tan of 37 to the nearest whole number. No. 6 to the nearest whole number is 7. So that's 7. That would make that 15. Right, one last problem for you to try. Here's a building. Giant skyscraper. And we have 2 people. Okay? We have person number 1 and person number 2. And both of them are looking up to the top of the building. So they're both looking up to the top of the building. Okay? So as you can see, they're both looking up to the top of the building. Now, this person, the angle at which he's looking up at is 40 degrees. Obviously, it's a building, so it's straight up and down. That's 90 degrees. Okay? And we have a bit of information. The distance from him to the building is 20 meters. Okay? So, we also know the distance from him to the building. He's 8 meters away from the building. And what we'd like to work out is the height of the building. We would also like to work out the angles. Okay, so, and we're going to give everything to correct to whole decimal numbers. So what do I mean by angles? Well, we need to know this angle. Let's call this one x. We need to know this one y, this one z, this one t. Okay, so we want to know all those angles. So let's start with the very easiest stuff. Let's find the height of the building. Okay, so this building creates a right angle triangle. Okay, so let's see, do I have two sides? I have one side of the right angle triangle, I'm missing the other two, so I can't use Pythagoras. So I need to use sine, cos, or tan. So let's see, what do I do have? I do have an angle. I'm looking for opposite. I don't have hypotenuse, but I do have adjacent. And that is tan. So the tan of 40 must be equal to the height of the building divided by 20 meters, which is adjacent. And because this is a triangular formula and you're missing the top, you just multiply the bottoms. 20 times the tan of 40, you get to the nearest whole number, 17. So the height of the building is 17. So now that's 17. Now let's see what else information I can get on this. I also know this distance here, that's 12, because if he's 8 away and 20, that makes him 12 meters away. Now I still need to find some angles. So I need to work out some angles to help me. It would be handy if I knew him, because I already know him and that will allow me to find him. So let's try and find him. Again, I have to use sine, cos, and tan. I have two sides of this triangle. I have opposite and I have adjacent. So that means that the tan of angle at y is equal to 17 over 8. So I know the answer to this sum. How do I get y? It's from the previous video. I get the tan inverse of that and give it to the nearest degree. So the tan inverse of 17 over 8 is 65 degrees. So I'm going to put that in. Look, I'm going to pop that in there now, 65. So if that's 65 and that's 90, 65 plus 90 is 155. Take it away from 180. This one up here must be 25. Now, if that's 40, I don't know what that is. I don't know what that is. However, this is a straight line. So if that's 65, then x must be what's left from a straight line. 180 is a straight line, minus 65 is 115. And I have two angles in this little triangle. I can add them up and take it away from 180. And surprise, surprise, this one's also 25 degrees. So there you have it, a full junior cert question with a lot of work. Hope that helps.